Hello, everybody. So let me first share my screen with all of you. So in this session, I have already recorded sessions, 2 sessions for chapter number 4, where I discussed, purely um, regression analysis theoretically. So we haven't run any regression there. So if I show you, so these are the slides that I discussed in the previous 2 recorded session. But if you notice here, it says if you have 420 observations, standardized test score is equal to, this is beta naught cap minus 2.28, that is beta 1 cap times class size. Okay, so this is what we calculated using sample data. So what I'm going to do here, I will use STATA and first reproduce that result. I have not, uploaded that data to your course website because we will be using different data set, at least for chapter number 4. So let me discuss this STATA software, though succinctly. So I just opened this 19 PE19 version. I just updated to 19.5. So this is the command window. That is, whatever you write here, it will appear here. So this is basically the history. So sometimes you don't have to write it again. You just click this history and it will appear in the command window. This is your output window, this one. So your regression results will appear here. These are your variables. So this window shows all variables, and the information about all those variables are given here. That is properties and the number of observations, and all this information is here. Now there are several methods of uploading data to STATA. Uh, in the previous versions, we did not have uh, basically we did not have this option to import Excel data. But now here in the latest version, I think in version 18 as well, we can import. So let me show you first. If you have let's say if you have a data set in Excel format and you want to import from your data from Excel to your STATA, what you need to do, you have to make sure that your first row will be the variable names, right? So always name your variable in the very first row, and then you have all the observation after the first row, that is from the second row. So let me show you how you import data, Excel data sheet from into STATA. So go to File, and then scroll down and go to Import. When you come here, you will have so many different options, right? So if you have SPSS data, if you have SAS data, and these are all different formats, right? They're all been converted into STATA format, that is DTA data. So the first option is Excel spreadsheet. So I click Excel spreadsheet. Now I have data that I've already saved. So I browse. When I browse, I have several data set. So let's open auto. So if I open auto data, the software will ask me whether the first row has variable names. So I will check this, and then I click OK. So now I uploaded data to STATA, and you can see here the data will come appear here, the variables. So this is automobile data, make, price, mile per gallon, repair 78, headroom, trunk, weight, length, turn, displacement, gear ratio, and foreign. So this is the data that I uploaded using by importing Excel sheet. If I want to see this data, then you can see you have these two options. One is this. So this is basically data editor. Data editor, you can even edit data here, right? There's another option. You can copy data from Excel and then open this STATA software and then go to, let me close this, and go to this data editor. Go to this data editor. Right now we have data. If we don't have data, then you have all blank. Then click here in the first what you call cell and then paste. So the data will be pasted. So this is another method how to basically use Excel data into STATA format. Now, once you upload this data set, what you have to do, just close this. So once you upload your data, what you can do, you can save this data. So go to File, go to Save As. When you go to Save As, notice the type of the file is .dta. So whenever you see any data set with this extension .dta, it means is directly STATA data set. So you don't have to import. You just click this data will open this data set. Okay. So I'm not opening this right now, right? But with this data set, there's one problem that it doesn't matter, but sometimes it is important. Suppose if I want to change the label of these variable names, suppose if I want to write make, I don't know what is make. So let's say if I write make as make and model, basically, that is Toyota RAV4, like this, right? So I can change this by writing this command. This is what we call labeling, right? Or label command. So label, don't use capital letters in command. Label, variable. What is the variable name? Make, under the name category, right? Variable name. And whatever name you want to give, you just write in the inverted commas. So if I write make and model. So if I do this, you can see here, now the label is make and model. Similarly, you can explain all these, label all these variables, okay? So I have done this. And if you go to your course website, you will find this data set and the explanation of these variables as well. If you cannot find, let me know. I will also upload the explanation of all these variables. Okay, so let me close this data. Don't save and open STATA again. Now this time, suppose I've already saved data in the STATA format, right? That is .dta file extension. So now I'm going to open this data, the same auto data. Okay. So right now, I'm not opening auto data. I will open auto data in a moment. Let's go to open another data. Open, and I have this data. If you can see, it says California school data. So this data, this is in the DTA format. So I open this data, right? Right now, you don't need to worry about all these variables because there are no labels here, but you can do number of things. For example, you know that now the total observations are 420. So this is what I wanted basically to show you that, remember this 420 observations. So this is a California school data in different districts with class size and student performance, that is standardized test score. So I want to run this regression. First, I'm going to show you how you run this regression, and then I'll proceed with using another data set. So there are only two variables that I'm more interested. Variable number one is, so this is the command for regression. So I just write reg. This is the command. I will write reg. What is my dependent variable? Standardized test score. So I can tell you where is this variable. This is test score. So if I double click here, it will appear here automatically, right? So this is test score, that is student performance. And then I see student teacher ratio, that is class size, which is this variable. So I take this variable. And then we write comma and then write robust. Now, we haven't discussed this robust command because this we will discuss this topic in later chapters when we will talk about homoscedasticity and heteroscedasticity. So right now you don't need to worry about this. Even if you don't write robust, you will get regression result, but slightly different than what is reported in your textbook and also in the slide. So that's why I just wrote robust and I hit enter. When I hit enter, you can see I have this regression results. Right now, number of observation is 420. By the end of this course, you will be able to interpret everything in this regression results, right? That is what is F, what is probability F, what is T, what is P, what is confidence interval, what is robust standard error, everything. But right now, in chapter number 4, we talked about only couple of things in this table, which I'm going to tell you. First, number of observations, simple. So basically your sample size is 420. That is number one. R square, we discussed R square. It is 0.051. If you remember, this is the number that I showed you somewhere in the, I believe, here it is. See, R square is 0.051. This is actually this number, 0.051. That is only 5.12%. The independent variable is explaining the variation in the dependent variable by only 5.12%. That is the remaining 94.8% is not explained. So it's explained basically it's error term. So this is the variable. The constant means basically beta naught, right? Intercept. So beta naught is 698.93. If you see, it says 698.9. So this is round this off number. So instead of writing 698.9, and then this is 2.279. So I can write 2.279. Okay. So let's exact same. Oh, okay. So they changed, sorry. 2.28. Okay, let me see. Yeah. So 2.2 instead of 7, we just round this off to 8 and with a negative sign. So we know these coefficients, we know the meaning of these coefficients. That is when you increase class size by one student, the standardized test score will decrease by 2.28 points. Okay, R square is 0.50512, that is 5.12%. And you see SER, that is standard error, standard error of regression is 18.6, which is a slightly different name here. We call it root mean squared error, which is exactly the same thing. No, not exactly the same. Hold on. No, this is different. 18.6. Yeah, this is same. So 18.6. So this is here it is standard error of regressions or root mean squared error, which we'll discuss later on. And I told you in chapter 4 that if you run a regression and you have high value of R square, then root MSE will be lower. So they are moving in opposite direction. As more percentage variation in the dependent variable is explained by independent variables, R square will increase, but root MSE will decrease. So this is how you run a regression. Now let's open another data set and do some other commands that are very simple, and you will need these commands for your assignments, and that is why I am doing this. So I will close this and I reopen this STATA again, and I open this time auto data. This is auto data. No, our auto data, growth data, earnings and height data have already been uploaded to your course website in week number 3 and 4 folder. So I open this. So once you have the STATA software, just download that auto file on your computer and then open using the STATA. So you just go to File, Open, and then Auto, and then Open. So now I open this data. Notice this time I make all these labels. But I want to change this label because it says make and model. I want to write M with capital M. So I can do this, the label command. So I write label make, label variable make, and this time I write make and model with capital M. And when I click this, hit enter, I change this make and model, right, with the capital M, both make and model. So I have this data. Now let me explain a little bit, and then I will do a few things. Number one, make and model, price is price, mile per gallon is mileage, basically. Rep 78 is repair record 1978. Headroom is basically headroom in inches. Trunk, that is the trunk space in cubic feet. Weight, that is in pounds. Length, that is inches. Turn circle in foot, that how many space you require to turn a 180 degree, right? Displacement, that is cubic inch. This is basically a size of your engine. So sometimes we give this information in cubic inch. Sometimes we give this information in cc, cubic centimeter, and sometimes in liters, 3.2 liter engine, right? So this is basically the size of the engine. Gear ratio, and finally, whether the car origin is foreign or local. So this is the whole data. Now there are a number of things that you can do. Number one, first, if you want to see this data, go to data editor. This is edit, and this is data editor browse. That is when you click browse, you just have this data, but you can't edit. You can't change any number. If you write 2 and whatever you type, it will not work, right? So it's totally, and if you want to get rid of this and go back to your original slide, just, close this. So I can see the data. If I want to see, I can see all this data here. Okay, I can see it. So you can see the foreign data. So the foreign data, this is the variable foreign. So you have only two options, domestic and foreign. So there's no number. So this is what we call a string data. A string data means you don't have any number, right? It's just the some information or words, right? So this is what I've seen all data. Now I will close this and I go back here. This time what I'm going to do, I will open this. It is not do file editor. So I will open this do file editor, new do file editor. Okay. So I just click this new do file editor and I have this editor here. What is this editor? The editor is, whenever you write command here and you execute, that command will appear here in the history. Okay. In the history, you can see last time I run this regression. Oh, I run this command, right? Label variable, which is in my history here. But when I close this and open this, it will be all gone. So you don't know what commands you use earlier. So if you want to save those commands at the same time, we use do file. So in your assignments, when I ask you to run a regression, you have to create a do file and send it to me so that I know what commands you have actually used to get those results. Okay. But as long as you are on the same, if you don't close this software or program, then that's fine, because when you click this again in the history, you can see it will run again automatically, right? So let me open this. Let's open this. Right? So I open this and I write the same label. I write the good thing in do file editor. When you write just one letter, it will tell you what options do you have. So sometimes even if you forget the actual word, you will remember, right? But you have to know the first name. So I'm just labeling. So label variable. Let's say I am doing the same thing, make, and I'm reverting this, right, to the same thing, that is make and M with small letters, right? Make and model. So this is the command I have written here. If I want, I can write another command at the same time. At the same time, let's write another command. Label variable. This time I am going to change the variable. Let me see what variable price is with a capital P, no small p. Okay, the variable price, and I am changing this. I'm basically changing the label of this price variable as price, but with small p. Okay, or with all capital letters like this price. Okay. Now the good thing is in the command. See, in the command video. Oh, sorry, window. You can only write one command. The moment you hit enter, it will run. So you can't write all command at the same time. But in this do file editor, in the do file, you can run both commands at the same time. Now notice what I'm going to do. I will click this. It says execute the command do file. When I execute all these two commands, this make and with model with capital M will become make and small m model. And this price will become all in capital letters, right? See this. When I click this, it changes. See, price, make, and model. And this can be seen here as well. You can see uh, that I run these two commands, label variable make and label variable make. So basically, I run the command as well as I now can save these. How are you going to save? Just uh, save as, let's save as, and let's say this is do file. So let's name as, okay, so I'm not going to save, I will save later. Don't worry. Let me first do more stuff with this data. Now so let me describe this data, right? So I'm writing describe. And if I execute, then it will execute all command at the same time. So I don't want to execute all command. I just want this describe. So I just copy this command and write paste here, and I hit enter. So now I describe the whole data. Notice that make and model is a string variable. Similarly, foreign is also a string variable, that is domestic and foreign. Okay. And all the variable names are here. Now, suppose if I have another, let me go to STATA and then go to do file. So this is I've already done describe. Oh, sorry. Now I write, I just calculate another command. Let's take, if I summarize the data. So suppose if I want to know what is the mean, standard deviation, and other stuff about this whole data set. So I just write summarize or sum in short. So we just write sum. Even if you write sum, it will serve the purpose, right? So I will write the sum here again. So if I write sum here and I do this, then I have all the summary of the data. You can see make, so price, because the make is a string variable. You can't take the average of domestic and foreign, right? So price, so there are 74 observations. You can see here 74 observations. Averages are given, a standard deviation, minimum value, and maximum value. Okay. Suppose if I want to summarize this data, so if I want to, let's say, summarize this data, if, and I'm putting a restriction, if price is less than or equal to, I know the price, the maximum price is 15,906, right? So let's write 14,000. What is the meaning of this? It means that you have to summarize data by excluding all those values that are or greater than, otherwise it would be much less, right? That will be greater than or equal to okay, no, then we don't have many observation. Okay, well, I don't know what I'm doing, but both will serve the purpose. Let me check both, right? Let's first enter this and see what you get. So basically, you can see that I just included those values where price is less than or equal to 14,000. And then you can see the maximum is less than. So the value is 72 now instead of 74. And you have different, only repair 78. We have only 67 observation in this case, right? So you can summarize data with a condition as well. I can, I can click here again. And first, let me save this command, copy this command, and go here and paste here. So I'm just writing all commands here as well, right? Now I change this command to, and let's see what happens. If I write greater than 14,000, let's see what I get. Now with greater than, you have only two models, right? Or two automobile, just two, where the price is more than 14,000. So one is 14,500, the other one is 15,906. That's all, right? So you can definitely now summarize the data, putting a restriction, okay? And if you want to put other restrictions, you can, I can't, teach the whole software in just one semester. And, every version, they are introducing new commands as well. So but you can, online, you can check the commands, right? Now, why I'm doing this? Because of this. Look at this. So this is your assignment number 1. I'm not saying this is from chapter number 4, right? Because you have to wait till chapter 7 in order to answer these questions. Let me read this question. Using the data set growth that I've already uploaded, but excluding the data for Malta. So you have to exclude Malta and then carry out the following exercises. construct a table that shows the sample mean, standard deviation, minimum and maximum value for the series, all these series. So you have to put a restriction, right? So first you see the data for Malta, and then you just ignore that data, right? So you just say less than this value, like this. So I'm just giving you a hint. I can't give you the answer, right? And I'm showing you with a different data set, not growth data set. I'm doing all this on basically auto data set. Okay, so you know what is command summarize or sum. Now, you can also summarize only one variable as well, like this. So for example, if you want to summarize only price, only price. So now you have the summary of only price variable, that is mean, standard deviation, mean, minimum and maximum for the for all 74 observation, right? But suppose if you want more information about the data, not just mean and standard deviation, minimum and maximum value, I want skewness, I want kurtosis, all this that we discussed in the review section. You know, if the skewness is equal to 0, it means the distribution is normal. And if the kurtosis for the normal distribution, kurtosis is equal to 3, right? So let's take the price. Suppose if we draw the price, if we take the price variable and see whether it follows the normal distribution or not, we can do this by this. I write summarize, right? Summarize price, price, comma, detail. We just write detail. So you could have written sum, comma, and detail. If you write just sum, comma, and detail, you have all the details for all variables. But I'm just interested in, okay, let me first do this, right? Sum, detail. Look at this, what you get. No observation. No, okay. So you can see you have all this data. Variance, skewness, kurtosis, and all percentile, smallest value, all this data is here, right? But if I'm interested only one variable, then I can write sum, price, detail. If I write this, so I have this data for price. Notice the kurtosis is more than 3. That is for sure that your distribution is not normal. And also the skewness is not 0. Skewness is positive 1.6. It means you have a longer right tail in the distribution and shorter left tail. And also 4.8. So you may have a very large value. That is, you may have outliers, not in the real term, but you have extreme values as well. But, so we can check this. Although this point is basically, we will discuss this topic in chapter number 15, almost at the end of the semester. But I'm now just mentioning so that you remember. When I reach to that topic, I will discuss them again, right? So now I'm going to draw. I'm going to draw histogram. Histogram for price. So this is the formula to calculate histogram. So why not I first do this? So I have done first I summarize only price, right? And then I summarize detail, and then I use summarize price detail. Okay, so I have all skewness and kurtosis. Now I'm going to run histogram, HIST, histogram, and price. Okay, so this is the last command which I'm writing here. So histogram, price. See what you get. So this is the data for histogram. You have price, and this is the basically density function, probability density function, right? So But I don't know where, it looks as if this is not normal for sure, right? Because you have very high value here, and then you have long tail, right tail, not left tail. What if I superimpose a normal distribution here and see what shape would I see if I draw a normal distribution as well. So you can save this graph, but right now I'm closing this. So what you have to do, you have to just add one. Oh, sorry. Go here, and what I'm going to do, I will write this time histogram price, and then I comma, and then I superimpose normal. That is, now I am fitting a normal uh, curve on this price data only. So I copy this. Okay, why should I copy? I go here, I click this, and then I write comma and normal. And now you see. So look at this. So this is definitely not a normal distribution. It's a very long right tail. It means what? It means that it has a positive skewness, and you can see the higher value is this much, not this much. So you have very high level of kurtosis. That is very high value of kurtosis. So you may have extreme values as well. So we will discuss this topic in detail in the last special topics, right? When we discuss non-parametric statistical methods. Right now, even if you don't understand, that is totally fine. But there are, okay, so now suppose, and that is useless, but I will do it uh, for you. So sometimes you sort data as well, right? So for example, if I have to sort data with respect to mile per gallon, and I click this mile per gallon. So basically I sorted the data, sorry, uh, in mile per gallon. Let me go to data set, that is data editor. If you see, this is mile per gallon. Now it is sorted. So the whole data is sorted according to mile per gallon. So you can sort with any data, right? So remember, I sorted. Let's sort with prices. So I'm writing here just to make sure that you have all command here. So histogram. So I'm writing now sort, and I show you sort MPG. Now I am sorting the variable with price. Okay, with price, and see what happens. So I will run this. Instead of MPG, I write price. Okay, and I run that. So I sorted the data now with prices. So if I go and see the data, actual data, so price is this. So now I sorted this out, right? Now from lowest to highest. Now see, there are only two vehicles that have more than 14,000 price. And you can see these are the two vehicles that we have uh, more than 14,000, right? So similarly, if if I give you a data on different countries, you can always sort data and then see the value of Malta. That is in the assignment question, and you can read the data on Malta, and then you put restriction in such a way that you basically exclude Malta in your analysis. That is excluding Malta, and then you just do your work. Okay. Now, so let me data editor. I'm closing this data editor. I don't need data editor right now. Okay, so I just now for a string variable where there's no number, right? You can also check this variable by this command, right? So by the variable is foreign, right? The name of the variable is foreign. You can see here in the variable, this is foreign, right? So this is the variable by foreign, and then always put colon. So by foreign, colon, and then sum summarize. I sorted. Hold on. Okay. So first I sort data according to foreign. Okay. And then by foreign, colon, uh, summarize. So now you can see that you have the data for foreign when the it's a domestically produced automobile. This is the data for all domestically produced. That is total basically 52, and this is the foreign vehicles or produced outside US. Now, if you want to, you can also use tab, that is tabulated, and you can write this tab foreign, then you have this data. That is, you have domestic 52 automobiles and foreign 22. Why then we have number 48? Because maybe for the 4 domestically produced car, we don't have data for repair in 1978. This is the reason. Data is missing, right? So we can also examine string data as well. So I will write here tab in the, so this is the data. So tab. So whenever you write command by foreign, you have to first sort, right? Remember. So I'm just, okay, let me write here. So if I write by foreign, colon, summarize, let me write the full summarize or some same thing. But this will not work, right? What you have to do before this command, you have to run this command. That is, you have to sort foreign first, which I forget, and that's why I have error. So let me run all these variables once again, all together. So if I go here and see if there's any error or not, if I execute this command, see everything is done, and you can see here, I can show you all this is again done, all this again. So I run all these commands at the same time. Okay. Now let's do this. You don't need, but I'm just writing because sometimes we need numbers, exact numbers. For example, you know what is the meaning of sum price, right? That is summarized price. So suppose this is the price. Now, if I need to just know what is the exact number mean, right? What is the exact, value of this mean? So I can write this command. I can display, right, with R, and then I write mean. If I click this, then I have this exact value, 6165.2568, which is here, it is 257 because rounded is off, right? So round this number off to 3 decimal point here, but you can have this. So you can do this as well. So I will write here in the do file, first I write summarize price, and then I write display because I'm summarizing price, display, and R and B. Okay. Now, now we run regression, right? As we showed you earlier in the PowerPoint slide. So I want you to run this regression. For example, if I want to see what is the relationship between mile per gallon and displacement. Remember, displacement is nothing but the size of the engine. So what I'm saying that mile per gallon, that is average mileage, depends on the size of the engine, right? So if engine size increases, of course, mile per gallon will decrease, okay? Because you have a bigger car, basically. So you need more fuel. So I'm just going to run this regression, and you know the rule or the code, the command, sorry. Just write reg regression and then mpg mile per gallon. The independent variable is displacement. I could have taken other independent variable, but since in chapter 4 we are dealing with only one regressor, so I just took one variable, independent variable, that is displacement, and then I write robust. When I write robust and I click this, so I have this regression similar to the one that I showed you earlier. So linear regression, number of observation 74, forget about F, probability. R square is, look at this R square, is 0.49. So it's almost 50%. So displacement will explain the vehicle's average by 50%, right? And of course, there are other factors as well, whether you are driving on the highway or in the city, there are so many other factors as well. Constant is 30, and look at the displacement coefficient, 0.044 with a negative sign. And that is quite logical because when engine size increases, mile per gallon decreases, right? So these two variables are moving in an opposite direction. And that is why we have a negative coefficient. So, but there are other methods. Basically, in the assignment, if I ask you to run a regression, what you can do, you first go to open the do file and write here. So write here, regression, MPG, and so that I can replicate your results. Displacement, comma, and robust. We always write comma, robust, and I'll discuss later on, right? So when you run this regression, you get this answer. Oh, sorry. You get this answer, right? Now, so in the do file, you send me the do file, and for the results, you can copy and paste this result. And there are methods to save this result in Microsoft Word file. You just Google and see how you can do this. So you have to open the session and end the session. Okay, if we will do this later, not in today's session, but I can tell you we can make tables as well in STATA, and I'll show you a very simple table. If you're more interested making more complicated and more information in the table, then you can go to the help and learn from there. Because of the positive time, it is not possible to discuss everything, but I'm just giving you one simple example. So suppose I'm planning to make this table. So this is how I'm going to make this table. First, I estimate. So estimate, I will store the value of the estimated values basically, and I will write the name as, let's say, regression 1. So I just store regression 1. I enter this. So basically, I have stored the results here. If you can see here, I'll show you in the variable folder, you can see estimate regression 1, right? This is I store. And then I using the command of e-tables. So I write e-table, and then I write comma, and then I write estimate, and I call it regression 1. I write estimate regression 1, and then I write mstat, mstat, uh, in the bracket, uh, R2, because I want R square in my table. So I like this. And then I am also interested in number of observation. So I write mstat uh, in the bracket, and that stands for number of uh, observation. You can add more, commands to include adjusted R square, to include stars, to include significance level, and there's so many things, right? So if I enter this, then you have this nice table. Your dependent variable is mile per gallon. Displacement is your independent variable, 0.004, that is this coefficient. And in the bracket, you have a standard error, 0.005. Intercept, a standard error, R square, 0.50, and number of observations. So this is a nice table that you can create. Okay, but you don't have to. You can, even if you copy and paste this table, that will be sufficient, basically. Okay, now so normally what you do, I'll discuss in the next when we discuss other regression STATA. So you can see, if you go to file and you go log, you just first begin before running any regression, and when you are done, then go and then close. Once you close this, then the software will ask you where you want to save all this stuff, and then you save that file. So all the output window will be saved. Okay. So you know the regression as well. Now, finally, I just want to draw few graphs so that and we will do later as well. Lots of graphs we will learn how to draw here. Okay. So first, I am just drawing the simple graph. So we write two-way, and there you have other options as well. If you go here, graphics, right, you can draw different types of. Remember, I just draw histogram. That is histogram. You can draw bar chart, dot chart, pie chart, and tons of different types of plots, right? But I'm right now here. I'm just drawing two-way graph, scatter, line, etc. So I'll stick to this one method, two-way. Histogram we will discuss at the end of the semester. Two-way, and then in the bracket, I write scatter. So I'm interested in two-way scatter plot, okay? And scatter, then I have to give two variables. Let me give MPG and displacement. Okay. So this is the data, and you can see we have a negatively sloped line. If you draw a straight line, that is, if you run a regression and fit a line using least square method that we discussed theoretically in chapter number 4, we can draw a straight line and predict or calculate the beta naught cap and beta 1 cap. We can do this. So how we can do this? You can save this graph as well, but I'm going to close this graph. So let me first save this, right? Oh no, hold on. So I have so many other, so regression, copy. I'm just saving in the do file, right? Oh, I have already done regression. Oh, sorry, I have already done this. what else? Oh, estimate. Yeah, I don't have these. So this, I will go to do file and I save this, and then I save another command that is table. Okay, copy, and I go to do file and I paste here. Do file, paste. Okay, so I paste these two files. Okay, now I've already done two-way. I've already done two-way scatter plot. I copy and I paste two files so that everything is in one file. That is a good thing about do file, right? So if you have to redo this whole stuff again, you have all the commands, right? So two-way. Now, if I want to fit a straight line as well, right? That is, we run a linear regression and the software will do. You don't have to separately run the linear regression. So this is what you have to do. So you write two-way, and then in the bracket, first you write LFIT, that is linear fit. So you are regressing, right? You are running a regression basically. What are the two variables? MPG, mile per gallon, and displacement. Okay, this, and then you have to also plot scatter points, right? So you have to also plot scatter. Okay, and then the same two variables, MPG and displacement. Okay, and then you click. So now you can see, now we have fitted values. So this is the line that we estimated. There are so many options. There is option that you can actually write the equation of this line on this graph. And there are so many other options. For example, I can show you but it will, you can play now because I'm just introducing this software. So if you go to graphics here, if you go to two-way, and you can see you have so many options, right? You can change the titles, you can write this legend, you have different conditions if you want to put, you have different types of plot as well. And there's so many options you have here, right? So I plotted these two lines as well. So I guess that is all as far as this session is concerned. I think I've discussed so many things. So you have to now you have time to just review and make sure you read assignment number one. Go just upload this growth data and try to solve this. You will not be able to answer all of these questions, all of these parts basically. So at least you should be able to answer part A, part B, and part C as well easily. Part D, you will have to wait for other chapters, right? That is up to 7. Okay. So now I will just close this file. I'm now going to close this do file. Now I save this do file, right? So I go save, and I save as this file. And let's say I name this file as do auto, right? Class 1, suppose, and I save this. So I save this file, do auto class 1. Now I can close this file. So I have saved everything, right? Now I close this STATA. I won't save anything. That's it. Now I reopen. I go to first data. So I open and I open the data. The data was auto, right? So this is the auto data. I open auto data. And then I go to, I open not auto data, but do file, which is this do auto classwork. I open this file. So I have the same commands. Now, if I just execute my command, I have everything here. See, this is what we have done. Everything is here. And if you go to the uh, output window, you can see you have everything again. So this is very, do file is very, very, very very important, right? So that you don't have to memorize. And when you submit something in your assignment, you have to send me the do file as well, that you have used these commands to create those values. Okay. So that is all as far as introduction to STATA is concerned, particularly with reference to or related to chapter number 4, that is regression analysis with only one regressor. So let me stop here. When I start chapter number 5, I will once again show you some data, and we will run few more regressions. This time, maybe a dummy variable, that is a variable that has only two values, or binary variable 0 and 1, and then we see how to interpret those coefficients. So that will be the next recording. So that is all as far as this recorded session is concerned. So I'm just going to stop sharing, and I am now going to stop recording as well. Thank you so much for watching this recorded session. Take care and bye-bye.